Hello everyone, welcome back to my YouTube channel Data Speaks. In the previous video of the series of regression machine learning in stock price prediction case study, we learned about setting up environment and importing necessary libraries and modules and importing data. We learned about exploratory data analysis from basic data exploration up to advanced data visualization. In this video, we will advance to the next step, which is actually training machine learning model and evaluating the performance of the machine learning model. That includes importing all necessary libraries for training machine learning model evaluation, and model parameter tuning to make it better and make it more accurate. We will check all the assumptions of the linear regression model if they are satisfied or not, and then we will actually train the linear regression model on our training data set. We will test the model's performance on the test data set, whether the model is accurately able to predict on the data set that doesn't have a label. We will try to understand the summary table from ordinary least squares and also understand each and every components of the summary table. At the end of this video, we will try to evaluate the model's performance and see if the model is able to accurately predict on the unseen labels, and also we'll see if it is doing great job on the training labels as well. So welcome to this video, and let's straight dive into the case study. We will begin by splitting the data into training variable and target variable, or we can say independent variable or the dependent variable. In other words, we can say predictors and predictive variable. So these are a couple of synonyms here. I will type out for you so that you understand what are those difference or how different ways the training and target variables can be called. We call them the independent variable or features or predictors to X that are going to be used to train the model, and then we call either dependent variable, target variable, or response variable, or predictive variable, and we call them Y in our splitting into the training and target variable. Once we have that idea, now it is time to split the data. So we'll call X equals, will include everything but the close price. So here, if you see, we have a trade volume, and also we want to include all of those year, month, day, and week number that we have created from our feature engineering section. And for the Y, we are going to predict the close price. So we'll call DF, and this way we will subset our data set. So double square bracket, open with and close with. Now in the same way, we have a DF and only one feature is available there. So we are saying only one square bracket, open close, for the close price. So we have our X and Y ready to be taken further for the machine learning model training steps. The immediate next thing we want to do here is creating dummy variables for the categorical data. So in our data set, the categorical data we have here is year, month, day, and week number. So we will create the dummy variables for those. Idea behind creating dummy variables is to be successfully be able to convert the categorical data into the numerical one-hot encoded representation. If you want to know more about the one-hot encoding logic, please do not forget to check my other video in YouTube channel that will explain step by step of one-hot encoding and also the label encoding. Please do not forget to check those. For now, I will create the dummy variable using pandas get dummies function. I'll call this X variable here, and I will call out the columns, which all the columns I want to create the dummy variables for. And I have a drop first equals true, which will ensure that the very first column is dropped. In that case, even if the one column with the 1 is not available, rest of those are 0, then it will by default machine learning model will consider there is a one column which is not present, but that represents to be 1. So that is the idea behind pandas get dummies function and drop first equals true. Once we create the dummy variable, we will be able to override these categories with created dummy variable having the same variable assigned. Let's run the line of code and let's get the dummy variable. As soon as I executed this line of code over here, you can see there are 101 columns being created. So you can see from left to right, we had open price, high price, low price, trading volume. And after this, you can see that we have year 2019, year 2020, 21, 22, etc. created. You can see false here. False simply represents 0 in this case, and true represents the value being exist in the data. So month here, you can see true. That means for that row, we had month 2 being true. For this row, the month number was 2. That is why we have true here, and month 3 is not there because 2 is there. It was a February data. That is why 3 is false, 4 is false, 5 is false, and likewise we have all of those rest of the months to be false. And you can see the day here. Whichever day is true, we can see that is a true, rest others are false. That is the idea behind creating dummy variable. You can see the week numbers here from week number 2, maybe up to it is going to week number 52 if we have the week 52 in our data. Even we have a week 53 as well. So maybe it was a leap year and we have the larger set of data, and all of those categorical data has been converted to the numerical one-hot encoded format. The immediate next step we want to take here is to do the train and test split of our data set, so that we can split our data set into the training and testing set. Here for this case study, we want to do the 80% of the data set we want to use for training set, and then 20% we want to split into the testing set, so that we can efficiently perform the training and provide enough learning to the data, and we can also have enough subset of the data to test if our model can accurately predict on the data set that does not have label. So let's do the trend test split over here. First, we need to import the library that is required to do the trend test split, and we will import that using scikit-learn's model selection module, and we'll import the trend test split from there. So if I hit run, and now I have imported the necessary library, and now it is time to split the data into the training and the test set. So here, trend test split is a function that gets the x and y that we have just split it and created the dummy variable, and here this represents we want to use 20% of the rows out of all the rows to test the model's capability on unseen labels. And now we want to set the random state to be 42 to stabilize the randomness while splitting the data and rerunning the code again. We don't want to mess up what has been already created as a subset from our data. And now we can quickly check what is the shape of the split we have over here. So you can check what is the shape of the training and then test on the x and y, all the labels. So here x train, same as x train and y train, we have 807 rows and 101 columns, and y train shape is 807 rows with one single column, which is closing price. Here x test set, you can see we have 202 rows with the same number of columns here on the x test, and we have on the y test set we have 202 rows, same as over here, only one single column with the closing price. So we have our training and the test data set ready. We will now import the linear regression model and then fit and train the model on our training data set. Let's now go ahead and import the linear regression model from scikit-learn, and you can always refer the documentation and understand more about the linear regression model in the scikit-learn's linear model module. Here is the documentation of linear regression model in scikit-learn framework, where you have all necessary components and parameters of the linear regression very well explained, along with the example code already provided for you, so you can always refer and understand and learn more about the linear regression model more in detail. Also, in my other videos, I have done the case studies on many more data sets in many different ways. Please do not also forget to check those tutorial videos on my YouTube channel as well. So that being said, we have just imported the linear regression model. It is now good time to go ahead and initialize the linear regression model with, we will call the linear regression model to be LR underscore model, and we'll call linear regression function that we have here imported from our linear model scikit-learn module. So as soon as we hit run, we have initialized our linear regression model. Now we can call our model and say dot fit x train and y train. That means we are training the model here with our training data. So this is how we will train our linear regression model. As soon as I will hit run in this specific cell, it will actually fit our training data and the linear regression model will be trained. It quickly went through because it had a very small set of data. Our X train is barely 800 line of data set, which did not take so much of the time to train. Now it is important that we evaluate the model's performance to ensure that we have a good accuracy on the training set, and also model is able to generalize enough on our test data. So what I would like to do here is define a function that is said evaluate the model, and we'll call model here. What is our model? That is going to be LR model. That's what the model we have trained here, and we'll call X train. So we'll use our training set of data to evaluate the training parameter, and also we'll use our X test to evaluate our model on the test set. So to do that, I will call training score, and I will say model dot score. So on our model, what is gonna be our training score on our training data, and I would like to call test score on our test set of data. That means this will give me the prediction score on the test data. It will give me the prediction score on the test data. So that is what is the idea behind printing these numbers, training score and the test score, which is going to be R squared value. R squared value explains the variability in the target variable explained by the independent variable or predictors. That is why R squared is one of the most powerful way to evaluate any regression machine learning model. R squared is not only the measure to evaluate the model's performance. We need to also check the error matrix in the model. We will check the error matrix on our training prediction and also on our test prediction. We will check training mean absolute error on our training label against the predicted training label, and also we'll check the test mean absolute error on actual label that we have but we never provided to the model, and we'll take against the model's prediction that has given for the unseen labels. In the same way, we will also try to get the root mean squared error for the training set and also for the test set. To do that, we'll call our mean squared error library that we have imported earlier over here, and we'll also get values squared so that we will get the root mean squared error, and we'll print those values for the training set and test set both. With this function, our model evaluation would be so effortless, and we will get every single scores we need, including R squared, mean absolute error, and root mean squared error all in once in one place. So this is pretty robust and powerful function that we'll be using to evaluate the model's performance. Let's call this function and let's evaluate the model. So I am going to call this function called evaluate model, and I'm going to provide every single parameter that is needed by the model, including the model name and then training set and also testing set of our data. Here is our all the inputs required for this model. Let's run this code and let's get the output. So here, our model has really outperformed on the both training and the test both set of data, where model outperformed almost close to 100% R squared on the training set where the model already saw the label. However, model also outperformed when model did not see the label, and error matrix are pretty low on the score perspective. So higher the R squared value, better the model's performance is on the training and testing both, and lower the error matrix are, better the model's performance is. So by this technique, we have seen that model has really done a great job. Now it is great time to look at the ordinary least square table, the summary table that provides overall bigger picture of the model, including F statistics, p value, t statistic value, standard error, and coefficients of every single features in the data. So let's go in the next video and let's do the summary table along with the model deployment into the Streamlit application that we want to deploy this model and use as the web application to predict the Netflix stock price more efficiently and more accurately for the future, looking at the historical data. So I'll see you in the next video with the ordinary least square summary table. Thank you for watching, and if you have not already subscribed to my YouTube channel, please subscribe and share with others so that you can learn and others also can learn. And please hit that like button if you like this video. Thank you for watching. I'll see you in the next video.